Hi, Summer Academy. Miss Ravenel back with you today. Today, we're going to be discussing a very important topic, which is evaluating derivatives at a point. This is something that we'll have to do a lot in calculus. Evaluating derivatives at a point is basically saying, what is the slope of the tangent line at this particular x value? This can be really useful in a lot of instances, and especially in real world problems. Like if we have a derivative that represents the velocity of an object, we could say, I want to know what the specific velocity is at 2 minutes exactly, right? And that is different than knowing just the velocity function. So let's take a look at an example together. All right, so in this example, we are given a function f of x, and we want to find its first derivative, f prime, evaluated at x equals 5, at that specific x value. And we also want to find its second derivative, f double prime, evaluated at that x value, x equals 5. This second derivative idea might be new to you, so we're going to go over that together. So first, we'll need to find f prime of 5, the first derivative evaluated at x equals 5. Well, to do that, we will need to first find the first derivative function itself. We'll need to figure out what f prime of x is for any x value. So we'll do that just using our derivative rules that we've been practicing. So f prime of x is going to be the derivative of each term of f of x. Well, we know the derivative of e to the x is just e to the x. Our next term is this negative 5x squared. We use the power rule, so bring the exponent out front. Negative 5 times 2 is negative 10. And then decrease our exponent by 1. So this is just x to the first, or plain old x. And then the derivative of 10 is a constant, so that's a 0. So we can just leave it off. Great. So this is our formula for f prime, the first derivative for any x value. But we want to find f prime of 5, a specific x value. So we'll do that by plugging in a 5 wherever we see an x. So f prime of 5 is equal to e to the 5th power minus 10 times 5. And we can simplify this to say e to the 5th, a negative 10 times 5 is negative 50. So this is e to the 5th power minus 50. Awesome. Now we want to find f double prime, or the second derivative at x equals 5. So to find the second derivative, we literally just take the derivative of the derivative, right? F prime, that's called the first derivative. We can just take the derivative of that function, and that gives us f double prime, or the second derivative. We could keep doing this. We can find the third derivative, fourth derivative, fifth derivative. We're not going to do that super often in this course, but the second derivative is something that will come up quite frequently. So first, we need to find f double prime just in general. F double prime of x, we need to take the derivative of f prime. So we'll take the derivative of each term. So the derivative of e to the x is e to the x. The derivative of minus 10x is minus 10. So our second derivative function is f double prime of x equals e to the x minus 10. So to find f double prime of 5 at that particular x value, x equals 5, again, we plug in and substitute a 5 wherever we see an x. So this will be e to the 5th power minus 10. So we have two key ideas here. To evaluate a derivative at a point at a specific x value, we first find the general derivative function, and then we plug in the specific x value. To find a second derivative, we simply take the derivative of the derivative. We take the derivative of f prime. You're going to get an opportunity to practice this now. Go ahead to practice set A.